Okay, I think we can start. It's 5. I'm German. I like to start on time. So welcome to the last slot of the day. And the last slot is looking into service-to-service invocation and also into the topic of causality. I think it's not going to be boring because we look into multiple tools, and it will be in like a deep and brief dive in at the same time. Well, what is causality and why is it important? So basically, if we talk about causality, the idea is that we have a certain action, and then at the end we have an effect, and we have a chain of things that is happening, and the whole chain is a causal chain leading to one effect. And I'm here at the last slot of the conference, and of course also there is causality in a conference setting, and I also like to use that for you to maybe have some reflection questions on the causality of that conference. And if we think of the conference, of course we try here to cause effects for the audience, and maybe as a thing to reflect causality from the conference are the questions: how did a talk influence your perspective? Which new tool will you try out next week? I think that's an interesting one. And did any networking interaction lead to a significant connection? So basically we look here at the causes. We don't see the effect. Probably you'll see the effect next week from the conference, hopefully. Let's look into causality in tech. That's why we are here. And in general, we can see certain things in tech as well. For example, a very generic example, I have high traffic, and maybe that increases my latency in my overall system. Let's put that more into context. Let's assume we have an ice cream shop. And we set ourselves an SLO, so service level objective, and we say to ourselves our customers should not wait longer than 5 minutes to get their ice cream. So we set this boundary ourselves, and everything that happens inside that boundary is still fine. So we don't look in the things that are, or at the cases that are inside that boundary, but once we start being outside that SLO that we set ourselves, once the average duration, for example, starts becoming 6 minutes, we set up alerts for the system, so we get a notification that something in the system is off and that we need to look into what has happened. And maybe then we do the investigation and we will see, oh, we have more traffic, we have more people looking for or wanting ice cream. But then we also realize there's also the sun that is out, so that's why more people are there. And I think it's a great example to outline, even though we often talk about that one root cause, that is a technical factor, the high traffic. It's not always the one single case, but it's related to a lot of things. And that makes causality in general more complex, because we are not only looking for the technical factor, but also for the whole process, how we have gotten to that point. And then another thing, well, that's the alert that we set up based on that system related to observability. And another thing that we do is, or that we need to do, and where we need causality is, what if I go to the ice cream shop and our dashboards are all green, but I'm the customer and I haven't gotten my ice cream after 10 minutes, and I'm now the really unsatisfied customer, and I'm the business problem basically. So we also need to understand what's going on with a single case in our system, even though our dashboards are green. And we need to be able also to look here, normally which services are involved and which service has called which service, to understand where the problem is and maybe where the specific problem got stuck. So we have basically those two types of causality when we look into our systems. And we need to talk about them because we are not dealing with simple systems, we're dealing with complex systems. We have layers of infrastructure, but also the service invocation over message broker gets more complex, and so understanding really what's going on is more complex nowadays. Well, we already had spaghetti at the conference, so that's, by the way, something that I will take with me home, like looking more into the modulus architecture. We also had Dapr already at the conference, which is great because I'm also outlining an example using a workflow for some of the causality we see. And just right now, we also had distributed tracing by the micrometer team, which is also great because that also gives an insight into causality. So I think we are done, and I can go. No, not that easy. So my name is Nele Uhlemann. I'm a developer advocate for Fiberplane. And I joined the company 1.5 years ago, and before I worked for a company called Camunda, more on the back-end engineering side and dealing with workflow engines, and with Fiberplane, it's a small startup, we are in the space of observability. And basically the whole topic around causality is something that came when I did the change from both companies, because first it felt like going from the one domain in software, the back-end engineering and system design, system architecture, to the operational side of things, to the SRE space. Observability is often tied, to the site reliability practice. So still in the kitchen preparing one meal, but not doing the main dish anymore, but maybe more looking at dessert. Luckily, in Germany and in other places, we have spaghetti as a main. And in Germany, we also have a thing called spaghetti ice cream. So there are similarities. And the one similarity I discovered in that phase is causality. And I thought, hey, let's look into the causal relationships that we have in different tools. And today, let's look into the call graphs. So let's look how we can build call graphs with our services. We go a little bit deeper into the tracing topic, and then also we look into workflows, and we will see how they all are able to show us causal relationships, but also how they are different from each other. And let's start with call graphs. And I think the really nice thing in the Spring ecosystem is that you have Micrometer. Who of you is using Micrometer? Okay, cool. All hands are up. That's nice. And you have really easy ways to use it to auto-instrument parts of your application. Even if you include the tracing bridge, for example, HTTP traffic is traced automatically, and you get information. And for example, if you want to display it, you need a backend for sure and a visualization tool. That's a call graph in Jaeger. So what you can do basically is you use the information you get out, and then based on that, a tool like Jaeger, and I guess Zipkin also is doing that, can draft you a call graph, and you get understanding how the interaction between your services are going. If we look into the cloud native space, we also sometimes have people using service meshes. Other vote here is who is using a service mesh in their organization? Less people, but still few. And with a service mesh, I also trace the traffic. So instead of sending the HTTP request from A to B, I have a sidecar. In this case, I put here Envoy. That's with Istio, or that's related to the Istio service mesh. And all the HTTP traffic basically is routed to that sidecar, to the other sidecar. And I can do more things here on the network side as well. So with the service mesh, I can also do retries and basically put the traffic on that sidecar layer. But also, if I have the traffic here, Istio also has a possibility to give me traces and generate call graphs. So in that case, I can use Kiali on top of Istio and Envoy for the visualization, and I get a call graph that has the same idea. It looks a little bit different because I have the service here, and I also start seeing different versions of the service. For example, here in review, I see the version 1, version 2, version 3. So I get a little bit more information how traffic is routed, and I also have a little bit more influence on the network, what's going on if I use a service mesh. But the basic idea is I can get already something out of the box to understand how my services are calling each other, no matter which tool you use. Then, interestingly enough, if we have a call graph on its own, it's not really giving us the information how long something is taking. So really, in order to make sense of our call graph or of our traces, we need metrics in combination, because only if we know how long certain things are taking, we can understand if a certain thing is off or if a certain thing still is in the boundary what we have defined. So for example, if we set a duration here, we see here the average duration, that's 15.16 milliseconds, and we can now define that we want to get alerted, for example, if this average duration is changing at one point. And then we can also see, based on the metric, on the numeric value, which spans are falling into the bucket of being handled still in time and which ones are not handled in time. You already see here that we are not only talking about a call graph, but the call graph is using basically tracing as the information to build itself. So let's look into what a trace basically means and what a trace is. So the trace basically represent the call chain of certain activities and certain services, and a certain call always is represented by a span. So the service A is calling service B, creates span 1.1, and then span 1.2 is created until the end and until the call is handled and finished. So basically we have the trace consisting of multiple spans. And one thing we should look into is, for example, if we use a service mesh with Istio and Envoy, what can happen depending on the technology is that you would hope here to see one trace, but often the case is you see two, because a new trace context is open after service B consumes the message from service A, and it opens a new span context and also a new trace context, and calls then service C. And that sometimes, well, especially in service meshes, can happen because we need to propagate the context manually. So if you use micrometer, a lot of that is done, but there might be even components where you also need to learn about this, so that's why it's here. So sometimes if you don't see the trace that you want to see, like one trace, but you have multiple, they are not connected, you need to look if the context is propagated correctly within your services. And that basically means you have the one trace ID where every span is connected to, but then you also have the span ID, which is a parent ID, so you can build the call tree basically on the trace. Well, and of course we not only have HTTP calls, we also have message brokers in between, especially in such a scenario when we talk about choreography and not directly coupling services. We also need to make sure to basically instrument those components of our application to be able to see the full trace if we want to. With micrometer, we can do that easily if we go into our Kafka configuration, into the factory. We enable there the observation, and then we can basically add a listener to the factory and also start getting information about our consumers, but also about our producers in Kafka. But this is something that we might want to consider if we have different components. With tracing, we have those two aspects basically, and that's general if we talk about observability. We can auto-instrument applications, so that's basically when you include your micrometer dependencies. Also, if you add something to your configuration, then you use the manual feature, the auto instrumentation features. But you can also go inside your service and you can basically start manually creating those traces based to your business logic. For example, if we look at a call graph, what we have normally is we have the outer edges of our service instrumented. So we see what hits service A and what's leaving service A, but we don't see, for example, all the internal calls that are happening inside service A, but maybe we also need that because we want to get more information here. Then if we talk about instrumenting applications, I saw already a lot of hands raising for micrometer. Still, I want to mention it because I think that's quite trending at the moment, and also it's one of the second, or it has the second biggest traction at the moment in the CNCF space. It's OpenTelemetry. And OpenTelemetry sits also here at the part of the instrumentation. It's language agnostic. It provides different SDKs, protocols, and so on to instrument your applications in both ways, the auto instrumentation, but also the manual instrumentation. And it was basically created out of two projects, Open Tracing and Open Census, with the idea to have a unified standard, because before you could imagine, I mean, not all languages have micrometer. Before you could imagine that those observability data backends where you store the information, for example, Jaeger created their own client libraries, and you would have a lot of different client libraries going for the instrumentation part. And OpenTelemetry is there a little bit to unify this. So you only have, or you start having a standard for the instrumentation, and it can go to whatever data backend. And I think it's a, I mean, it's at one point, at some points it's not that stable, but in other parts it is. But I think in general it's a good It's a good initiative because it makes it easier, theoretically, to plug in those observability data backends, so to change from Jaeger to Zipkin, for example, without the need of changing your client libraries. I mean, I would say so-so, because you still need to take care about your query and alerting in the end. So even though you can change here your data backends, there is still no unified query language, for example, so you still need to consider something here. So it's not like I switched my observability data backend like this. You still need to look into the query and visualization platforms. But yeah, on the Java side, it also supports an auto-instrumentation with an agent that you can run next to your Java application. And yeah, you basically start it up and you define where certain things should be sent to. And on the manual instrumentation, it also provides an SDK, but I'm a little bit hesitant to recommend it because Micrometer is really so good with all the instrumentation and so Spring feels so Spring native that it really doesn't make that much sense to look into that if you are using Spring. But maybe the agent can be something, but also there you have a lot of auto support for Micrometer already, so yeah, but still I think it's interesting. And I think it's also not exclusive because Micrometer only is a facade on your application and it's compatible with OpenTelemetry. So even though you instrument your applications with Micrometer, you can export them in the OpenTelemetry format, and for example, Jaeger natively understands the OpenTelemetry format, so there is basically not the need for you you can use Micrometer with OpenTelemetry basically, so if your SRE teams or observability teams want the OpenTelemetry format or so on, you can basically include that into your dependencies and then you get it in the OpenTelemetry format. And yeah, let's look into a demo with a tracing here, and for that we need an example application. And I like ice cream, I like food, so I came up with not an ice cream shop, but an ice cream recommender. And I have a recommendation service where I give some input that sends a message to Kafka. I have a location service that picks up where I am and calculates longitude and latitude for me, also publishes a message to Kafka. The weather service picks up the longitude and latitude, calculates the weather for the location where I am, and then of course we need AI in all the applications we are building. I have an AI service that is doing a prompt to a ChatGPT model, and based on those input values I get a recommendation for ice cream. The services are not calling each other directly. They use Kafka as a message broker here in between. So I have a choreography set up with 4 microservices communicating over messages. Yeah, let's look into this. And I'm already connected to my WebSocket, but I have here my name, I have the location Berlin. I also use that to understand what the weather is in Berlin now, so if I miss something. Also, initially I set diet restriction, but I mean, I tried out multiple things with vegan, vegetarian, lacto-free. It's getting a little bit boring, so let's try to get something out of ChatGPT. I say here something that fits to vegan currywurst, and my mood is quite exciting, and I can now send this request and wait some time. Yeah, and here it is. So I have a dietary preference for vegan currywurst, and there is lovely clear sky in Berlin. Okay, I think we maybe still have better weather. And we get the spiced apple sorbet as a recommendation. So let's look into the trace component, and let's look into how that looks into the traces. So I have here all the services that has been called. Maybe I need to make that a little bit smaller. Yeah, so I see here the services are calling each other. I think I forgot one thing in my slide to show, so I'm just jumping back here, because we need to look into the weather service. We come back to the trace later. So what I can do with the weather service, just the outsides, we saw the trace was consistent. With Micrometer now I can even go in and create those manual custom spans. And the key of that is basically the observation API. And the observation API in Micrometer is super nice because it's not only taking care of the trace, but it's also there for the metrics. So I only have that one API for metrics and for traces. I put this logic here just in my business logic, but obviously you can even abstract that, so you don't need to put it in your business logic. But the idea here is that the observation API has a life cycle, so I can start the observation API with a registry that contains also a handler that defines what I want to do at the end with my observation and with the trace. And then here I basically add events to my observation, and I can add certain tags, and everything that is a high cardinality value ends up in a trace, and if I have a low cardinality value, it ends up being in a trace and in a matrix. But so I can also enhance my trace with information about the weather, the business case, so the business key, and also my name, for example. I can throw an error for the observation as well if something goes wrong, but I also can then basically stop the observation here. And as said, normally you would also not put that directly in your business logic, but you would abstract that. And there was a good talk just at 2, I think, from the Micrometer team. If you haven't seen it, just watch it. It is really cool and includes a lot of features, what you can do, also with the handlers and with the documentation on the side of Micrometer. Yeah, and another thing you can do is, in a Spring way, even easier, or, well, what means easier, but you can also use the Micrometer API with Aspect. So you can give it a new handler, again, how you want to handle your observation, basically, and the registry. And once you have registered the observed aspect, you can use the observed annotation and basically give it the name with the weather fetch service. And now, if we go into the UI from Jaeger again, what we see, I mean, I run this case already. What we can see here is basically the one thing that I did with the observation API. So here I have my business case number, and I also have the weather, that is the clear sky. So those are now added to my trace as a span, and I can now put more business logic in. And I also have here the class that I annotated with the weather fetcher, and I have here the method that was called get weather fetcher get weather conditions, and so this also ends up becoming one part of my trace, and also it adds to the metrics. So if I go now to the address of the service and to the actuator endpoint, and let's look into the weather fetcher. I also see here the count value. I mean, I tried the demo out before, so I've called the method already 3 times, but just the annotation is adding the trace plus also the metrics to my code base and for the observation, basically. Cool. Yes. Let's jump back into the presentation. So what you can see is basically you get a causal chain with traces, but in terms of observability, you would not look into traces alone. A trace never gives you the information alone. You also need the metrics to make sense out of it. For example, if you want to understand latency, and if something takes longer, you need also to understand what are you expecting and what are you not expecting from your system. And you normally use metrics to define it. For example, an average duration of how long someone should wait for ice cream would be the metric. And then if you are off, you would use a trace for more information where the time is consumed. So which span takes more time. Maybe it's a database call, maybe something else, but it helps you in the end to debug issues. And the idea is basically that you can jump from a trace to a metric, from a metric to logs, and that you have the full cycle. There is a good blog post from the Spring IO team if you want to get started with observability and with the observation API, that I would recommend checking out. Cool. So now that we know that we can also add like a business key to our application, to our trace, I can probably also answer now the question if I have that one single customer that is not getting ice cream, right? Potentially yes, but it's not good practice, because normally with tracing you keep 10% of traces in your system, because if you add more, it's quite expensive, or well, trace storing traces is expensive, so there is a rule of thumb of only capturing 10% of your traces going through your systems. So it's not the tool that you need to, or where you could answer the question, what is with that one customer that is not getting the ice cream? And so where is my ice cream recommendation is the question. And let's look into a different tool. Let's look into workflows for that. Let's jump on the other side of things. And a workflow normally is a set of activities defined in a certain order and on a sequence, and it has a clear defined start point and a clear defined end point. And you have one workflow definition, and you can have multiple instances running on that workflow definition. Normally, you have a set of activities. For example, you start activity A, that can be a service, and once that activity is finished, the workflow will push the instance to the next thing that can be an event, for example, where you wait for external input, but it could be also another activity that is related to a user, where a certain user in your system needs to perform a task, and then at one point the instance ends and is consumed, and then the workflow is ended as well. And a workflow engine basically takes care of that state of your business operation. So whenever something happens or your system is going down, the workflow engine would know where your instance stuck and would also be responsible for keeping the state. And normally we consist those workflows if we have longer running things like durable executions. If users are involved or external systems, they can become quite handy, because then we do understand where we might stuck with our process instance. If we look into the ice cream recommendation service, we already have one service kind of responsible for state. So we have this one here, the recommendation service, that is already sending some input and waits for something to come back. So here, in terms of Kafka, I need to make sure that I correlate the message that I sent from Kafka with the message that comes back at one point from Kafka. So this service somehow already is the one that is responsible for giving something back and for containing the state in the system. So if we change that now to a workflow scenario, what we can do is basically we can give our workflow to that service and call the whole service, or that's the recommendation workflow service now. And we still can use Kafka, so it doesn't mean that the workflow is calling directly the activities. So we can still say that we want loosely coupled interaction with services that are not inside the other service. So for example, if we have the activity now with the geodata, so the location service, we send basically a message to Kafka, and the service that has been connected with Kafka before doesn't really know that it's part of a workflow now. It's still just consuming and sending Kafka messages. So there is no need for this service to know that it's related to that workflow. But handy here is now, if something goes wrong, we can ask the workflow engine and query here and ask, hey, what happens to that specific business case? And we get the state of that workflow instance and also can see where we are at. We also can listen for messages that come back. So we have the potential to look for external events coming back in, and we also have the potential to have this activity that before was our own microservice. We can also bring that into the service now and say, okay, maybe this is a server that runs really short. We want just to invocate it directly in the other service. That's fine too, so that also works. But yeah, that is the basic idea here. So let's look into a demo, and for that demo, I'm using Dapr workflows. Who of you knows Dapr? Some, not everyone. Has someone talked to Temporal from you? Because Temporal are also here as a sponsor. Some see that, okay. They also do workflows in code. I mean, I used to work for Camunda. They also do workflows. I choose Dapr because I'm also somehow interacting with the cloud native space, and I played around a little bit with the tool and I found it interesting. Just on the architecture level, Dapr sits also as a sidecar on your service. So each service becomes a Dapr sidecar, and then the Dapr sidecar handles basically the execution of a workflow. We only look into one service now and into the workflow definition. And let's do that quickly. Let's stop this one here so we don't get any problems. Yeah, and let's look into the workflow basically and scroll up. So what I do here is I define what I want to do in my workflow. I log basically things, and now interestingly enough here is line 33. Here I call for the first time the activity for the location request details, and I say also here I want to wait until this activity is finished. So at that point my process instance, the one customer, has to wait until this activity is finished, and then I can move on in the workflow. And what I do next is here I wait for an external event. Basically we have that activity. This activity is only sending out a Kafka message in that workflow, and then the location service that sits somewhere else is picking it up. And here with the external event coming in, we wait for a Kafka message to come back that we can correlate to the workflow. And what I can do here is now nicely is, for example, I can wait for this forever, but I can also say if this event is not coming back in 1 day, so I can give it a duration of 1 day, then basically I do something else. So I cancel the task, and then my customer is not getting a recommendation, it took too long. So now I have also the influence to be proactive. If things are taking longer for my customer, I can design them and I can change them. So I can say, okay, if a certain system is not replying after 3 days for a specific instance, maybe I need to look into this. Maybe I need to also reach out to the customer, send an email and say, hey, sorry, it takes a little bit longer, which is a way better customer experience. Well, and then I go on in the workflow. I can call different activities, and at one point I complete the workflow. And yeah, I also get the recommendation. The nice part here is with the recommendation, before I had to correlate my Kafka message, so I had the business key that need to be matched. And now I don't have to do that because I stay in the context of the process. So I know when this process is finished, I just give back the recommendation for that process that was started by this one customer. What I do now in my input controller is I create the workflow definition basically. There are probably also better ways to do that, but yeah. So I create the definition here, and before I start when I start the input controller, I'll also call the method, and then from here I can start with the Dapr workflow client, basically the workflow with some payload. So let's run this. I mean, shouldn't really change anything from my application, so I can just connect again. Now we are in Barcelona, and maybe, I don't know, something is not connecting. Let's see. Put this is up. Should be all okay. This is all Kafka things coming through. If someone sees a hint, let me know. Now it Well, now it's connected. Let's see if it works now. Maybe it just needed a little bit of time. Oh well, doesn't make sense, but at least I start the workflow. So now it's triggering basically based on the input. I scheduled the new workflow with a process instance ID. Oh, I know what's, yeah. Yeah, I think I have a container issue with my Dapr containers. That happened before. So even though they are up, that's unfortunate, but yeah, I have seen this before, so I think there is something going on here. I need to probably, let's do that quickly. delete them. Zipkin is there. Oh, Jesus. Yeah, Zipkin can't get the... Let's wait until Jaeger is a problem here. Sorry for that. That looks better. That is the wrong service. Why are we now in this? Okay, well, it worked before. I'm a little bit too nervous to debug it now. I have a screenshot for this situation. I think it has been in the container, I'm sorry, because it happened before. But yeah, so basically, yeah, if you run this now, the user experience is the same. We get an ice cream recommendation. What you see in the console is the workflow is locking the activities. So you get the information where your workflow is. And obviously, if you have a workflow engine, you can also now use the API from that workflow engine, for example, Dapr, to ask where a certain process instance is. So if a customer has a question, where is my ice cream recommendation? You basically can query with that process instance information the API and see where you stuck. And you get the information from the workflow, and the workflow takes care basically of the state of your business case, and also is there for retries, for example, but also for rollbacks if something goes wrong. So, well, let's sum this up. So in the end, we looked into different things in causality. They are, in that regard, same, that they all show us how services are invocated, but then there is a lot of difference as well. And I think it's not the one or the other, but let's start what we have seen with call graphs. So call graphs show us the network traffic if we use service meshes, and also show us service-to-service invocation, for example, with tracing. They are based out of traces, but normally what they do is they instrument the outer edges of our services, and we use them in the field of observability. If we want more information, we normally look into tracing more in detail, and we also look into manual instrumenting our applications to get more information into our trace. So not only looking into the one service-to-service invocation, but also seeing insights into the service. And then we get also more context, and it's all in the context of observability, and a trace alone doesn't really make sense for us to get more understanding. We need it in combination basically with metrics and logs. And then we also have, on the other hand, workflows. They also give us an insight into the causal relationship, but they are different because we use them already when we design and build our systems. So we define how the workflow looks like. We use a certain part of orchestration here, so we are not in a completely choreographed way anymore. So we start orchestrating our services, but what we get from it is basically we have a state management, so we start managing state in our systems. Based on a workflow engine, we also can define rollbacks and timeouts, and they are related to a single business case. So we can track down business cases that, for example, go wrong. And with that, I like to close the short excursion about causality in systems. And if you have any questions, I'm happy to take them. Thank you.
Thanks. So you say you want always to connect traces with logs and metrics. I think I observed initially when I started looking into distributed tracing, there was this, you only need traces. There was this opinion that except maybe some platform metrics, but then it was like you can get rid of logs completely because it can be just a span and you can have the same information in the span. And for most metrics, you can also derive them from traces because you can count things, aggregate, find latencies from traces. And I don't know if you ever know, but now I think that people are again going back to, no, we need all three pillars and just connect. I don't know if you have, if you also observe this and you have some opinion on this, or...
Yeah, I think the thing with logs is the same a little bit with tracing. Storing traces is more expensive than, for example, storing metrics. And I would argue if you accumulate a number, you always you start having a metric, right? So if you have an average duration of something, that's a metric in my understanding. So I think it makes sense to at least look into metrics and traces because you need to decide at one point where your system is not behaving. And I think the override circle makes sense. And then even sometimes, what if you see in a trace, for example, something takes longer, for example, database call, but what if you don't get more information then from that trace? Of course, you can put in certain tags and whatever into the trace, but maybe there is still something that you need to see in the log. So I think it's a good combination if you look at all three, or maybe it depends also a little bit on the use case if you need it, but I think in general that's a recommendation to look and set up observability with all three of them. Okay, I think. Yeah, all good. Yeah, thank you.